A log is like an app on your phone. Before you use the app, you have to set the base, B. So tell your phone what B should equal. And you need to set the input, A. You need to tell your phone what A should equal. And the application will tell you what the exponent should be, what the question mark should be. So because a log is saying, hey, what should I raise my base to? What should I raise B to get A, the value of the input? The phone app is going to be spitting out numbers that represent the exponent that you need to raise your base to. So look at the kind of numbers that your app spits out for the exponent. I mean, the numbers can be as high as 1,000. They could be higher than that. The app will spit out any number, but I want to start at looking at the number 2 and then going less than 2. So let's look when the exponent is 2. When it spits out 2, the app could spit out 1. It could spit out -1, -2, -3. And so you'll see as the exponent gets smaller, the app spits out small numbers. Negative numbers are small numbers. As the numbers get smaller for the exponent, look at what the A value is doing. The A value is getting smaller, but in a different way. The A value goes from, as the exponent gets smaller, it goes from 4 to 2 to 1 to 0.5 to 0.25 and so on. And look at how small it gets, all the way down to 0.00000000954. And as the exponent gets even smaller, like to -30, the number, the A value, will get small, really, really small, but that number will never, ever become negative, and it'll never, ever equal 0. So this means there's a restriction then to the type of numbers that you can plug in for A to be the input. You can only tell your log app that A value can be certain numbers. You can't plug in any negative numbers into that A value. You can't plug in 0. All you can plug in are positive numbers into that A value. So since that A value can only be positive, let's look at a log's input, the A value, that we've seen before. For example, how about log with just some common base B? Log base B of x minus 1. And so the input is x minus 1. So that A value is x minus 1. And if we consider some values for x that we can plug in, let's start with some values for x. So when x equals 3, you have 3 minus 1. That A value is going to equal 2, and 2 is positive. So that's an A value that'll work. When x equals 2, let's go down with our x values. When x equals 2, 2 minus 1 is 1. The A value is 1, and that's positive, so that'll work. Look at this next x value, though. When x is 1, you get 1 minus 1, which is 0. The A value is 0, and you can't have an input into a log that's 0, so that x value won't work. And then if you keep going down with your x values, so next when x equals 0, you'd get 0 minus 1. You'd get that A value equals -1, and you can't have a negative input into the log. So really, I mean, next x value, when x is -1, you get -1 minus 1, which is -2, and that's negative. So any value of x that is at 1 or less than 1, like x equaling 0, -1, -2, those values for x won't work. And so since the domain is all of the x values that are possible, the x values that you can plug in, well, every single log has a domain that is based off of the a value for the input. And so if you have a log that is x minus 1, then the domain is that x can be any value that's bigger than 1. X can't equal 1 because then the input for the log would be 0, and that won't work. X can't be anything less than 1 because then the input to the log would be negative. And so the domain is based off of the stuff that's inside the input to the log. So if the log's input, the a value, was x plus 5, well, the x value, the very first x value that won't work is when x is negative 5. Because you'd have negative 5 plus 5, which is 0, and that won't work. And x can't be any value that's less than that either. Because if x was, well, let's see, what's smaller than negative 5? Negative 6? If x was negative 6, you'd have negative 6 plus 5, which is a negative 1 that goes into the input of a log. And so the domain is always based off of the number that's paired with x. And it's always going to be the opposite sign, as you can see. So you have the domain that will be different for every log. And then you have something that's equally as important, and that's the asymptote. And the asymptote is a line that is on a graph, or it's a line that the graph of the function will get really close to, but it'll never touch and it'll never cross. Well, the line, that asymptote, is like a boundary line. It is the very first value that x cannot be, the very first value that you're not allowed to plug into x, because then it would give you 0 for the input or negative for the input. And so the asymptote is based off of that number that is with x in the input. It's based off, so if your input is x minus 1, the very first number x can't be is 1, positive 1, and it's the opposite sign. And so the asymptote is always x equals the opposite sign of that number. And we call it x equals, for in this example, x equals 1, because x equals 1 is a line. X equals 1 everywhere on that line. And no matter where your graph goes, up or down with its y value, that graph will never cross that line because x cannot equal 1. And the graph won't cross it because x can't be any values less than 1. So notice the domain, which here is x can be any value that is bigger than 1, the domain is very closely related to the asymptote. It's just that the asymptote is x equals 1, or the opposite sign of the number that's in the input. And the domain is just x being greater than that the opposite sign of that number. And so that's asymptote and that's domain. And for every one of these log functions, I'm going to need you to write down what the asymptote is. And I need you to write it down as an equation. So how you see me writing it in the equation form, x equals 1, you need to label it asymptote like I did as well. And the domain, you're going to need to find the domain for every log function before you graph it. And it's not too difficult. It just depends on the numbers that x can be. X can be all numbers that are bigger than, and it all has to do with the number that's next to x in the input.